about connecting rods and wanted to share with you a little bit of information about them. Connecting rod is one of the more important pieces that we put on our engines, and we want to make sure that we put the right ones in. I want to tell you a little bit about cast connecting rods, forged connecting rods, and billet connecting rods. This is a cast connecting rod, and the way we can tell that it's cast is this small little seam that we see on both sides. That's where the thing was actually cast in sand, and that's the parting edge. This was cast out of steel, so it'll do the job for a street motor quite well. This is actually out of a 3.8 liter Buick engine. This is a typical forged rod, and if you look at the parting edge, you can see how it's thick, and that's from the forging dies and the forging process that leaves a little bit of material behind on both sides of the connecting rod. This is what you might find in a small block Chevrolet. This connecting rod is a forged billet rod, and this is what we call an H-beam rod, meaning that the beam section here resembles the letter H if we were to cut this in half. Our forged rod and cast rods, if we cut them here and looked at the end, would resemble the letter I. So they're what we refer to as an I-beam connecting rod. The forged connecting rod, the billet rod, is machined from a solid piece of steel. And if you look, you can see that there's no parting edges because the total rod is machined 100%. Things that we would want to look at on our connecting rods is how they're fastened. In other words, the cap on this rod is fastened with bolts that go through the top, what we call the beam section. On this small block Chevy rod, we have a bolt and nut assembly to hold it together. And on our machined rod, our H-beam rod, we actually have bolts that are screwed in to hold the cap on. One of the newer technologies that we're seeing in modern engines is the sintered rod that's made from powdered metal. It's pressed together and then it's put into an oven where it's sintered. In other words, it makes it so that the granules are melted together and they form a nice monolithic piece. This happens to be out of a 4.6 Ford. What's interesting about this rod is that the parting edge, where the cap and the rod meet, is fractured. So that means that each cap and each rod is going to be unique unto itself. It's not uncommon for me to find rods that have copper plating on the small end and even sometimes the big end. And what that's from is from a process where they dip the rod into a copper plating solution. And the reason they do that is because at the factory the hole for the piston pin was made oversized, and by copper plating the rod we're able to reuse the rod and install a stock size pin. Same thing can happen on the big end, and you'll find some rods that are actually completely copper coated from one end to the other. This one here, you can see, just had a problem with the pin end. I'm often asked which rod is the strongest. The forged billet rod is the strongest by far. They'll handle upwards of 1200 horsepower without any problems. Forged connecting rods are good for an RPM range up to about 5500 to maybe 6800 RPM. Some people actually run them farther up the scale than that and have success. The cast rods, I would say probably the maximum RPM on these is probably about 6500 RPM. I wouldn't want to trust them much past that. The pressed metal rod, or the powdered metal rod, has an RPM limit of about 7,000 RPM. Anything after that and they get to be real tender and they'll break pretty quick. You can see that the rod itself, the powdered metal rod, has a real thin beam compared to these others. It's made for lightness, it's made for quick acceleration. It's an interesting point about these new powdered metal rods is that the housing bore, where the bearing goes, actually will stay rounder longer over the long term of life of the connecting rod than what the cast or the forged rods will. The billet rods generally seem to stay pretty round, provided they have enough oil and they have the right living conditions. Well, I hope this quick look gives you a little more idea about connecting rods, how they're used, and what they're made from. John Edwards, Costa Mesa R&D. We'll see you soon.